today. Who wants to learn how to rationalize expressions and equations? There's a reason we learned how to factor last time, and I'll show you why. We need to rationalize. So, if I'm given 3x minus 15 over 7x minus 35. Well, we're going to look at these, and we'll look at them as separate entities. So I'm like, okay, what can I take out of the top? Well, what I can take out of the top, my greatest common factor is a 3. When I do that, I'm left with an x minus 5, because I divided the 3 out of both of those. Well, what can I do on the bottom? On the bottom, I'll take out a 7. And then I'm also left with an x minus 5. Well, now, looking at this, we're just taking away what we can to rationalize it. Well, this cancels out and this cancels out, so our entire answer is 3/7. So we're pretty much factoring, which we did in the last videos. We learned how to factor. So that's the goal. Factor, and then cancel out what matches. That's called rationalizing. That's what we're doing. We're rationalizing these expressions. These are called rational expressions. So, if we're given one like this, where we have x squared minus 3x plus 2 over x squared minus 2x minus 8. Okay? So again, look at these like they're separate entities. So let's look at the top one first. So we multiply our a times our c. So a times c is 2. So you need factors of 2, factors of a positive 2 that add up to a negative 3. Your factors of 2 are 1 and 2. And they have to add up to a negative 3, but multiply to a positive 2. So if we do that, we know that both of these are going to be negative. So our top equation is x minus 1 and x minus 2. Let's do the same thing to the bottom. So 1 times negative 8 is a negative 8. And we need factors of negative 8 that add up to a negative 2. Well, I know the factors are 1 and 8 and 4 and 2. So looking at this, we need the factors that would make it a negative 2. I'm trying to see what I did here. Oh, no, it's not negative. It's a positive 2. Little brain. I wrote it down wrong, guys. So, knowing that, I need a positive 2 in the middle, but a negative 8 on the side. My 2 has to be negative. I wrote it down wrong. So, we're left with x plus 4 and x minus 2. Well, what matches? We can cross out these two, and our answer is actually x minus 1 over x plus 4. That's as far as you can go when you have just rationalized that expression. That is our goal, is rationalizing these expressions. So, let's keep going on this. Bear with me. I'm busy. What? Yes. You may eat your chicken wings. Okay, so let's look at something like this. X cubed minus 4x squared minus 5x over x cubed minus 25x. Well, first of all, again, we're going to look at them like separate entities, because they are. On this top one, I can take out an x. I know that much. And I'm left with x squared minus 4x minus 5. But we're not done, because we can keep factoring that one. So we need factors of a 1 times negative 5, so negative 5, that add up to a negative 4. Well, my factors of 5 are are 1 and 5, and to add up to a negative 4, but multiply to a negative 5, I know my 5 has to be negative. So my top of the fraction is x times x minus 5 and x plus 1. So this factored is this. So now let's factor this bottom one. I'm going to draw a line. So our bottom one, we know we can take out an x as well, because there's an x in common. And I'm left with x squared minus 25. But what did I teach you guys last time? We have a difference of squares. When you have a difference of squares, it's easy because it just comes in this form. X plus 5 and x minus 5. That's a difference of squares. So now that we have that, we're going to cross out what is common. Well, my x's are common, and my x minus 5s are common. So really, my answer is x plus 1 over x plus 5. And you have just rationalized that expression. Sound good? I hope you guys are kind of following me on this. Hi. The cat is meowing at me. He wants attention. So, what if I'm given... I'm trying to see where I can go here. So let's rationalize one more. Let's do something a little more difficult. So if I'm given 1 minus x squared over 3x squared minus 2x minus 1. So let's rationalize the top. The top, we're looking backwards. It's still a difference of squares. It's just written backwards. So it's a difference of squares. And we know a difference of squares is, but we're also, so what I did, what you have to do on this one, because right now it looks weird. And I like to rearrange things. So rearranging it, I don't even know what I did, honestly. I did something to this. I took out a negative 1, but why did I take out a negative 1? So I want to rearrange this. Okay. I want to rearrange this top so it actually looks better. Because if I rearrange this, it's going to actually look like this. And I want to make it a difference of squares, so I'm taking out a negative 1. When I take out a negative 1, then I get x squared minus 1. So there's my difference of squares. Now that I have the difference of squares, it's actually going to end up going to this. So there's my top equation. Now my bottom equation, I'm going to multiply my 3 times my 1, and I get negative 3. I need factors of negative 3 that add up to a negative 2. Well, I know I have a 3 and a 1, and my 3 is going to have to be negative. So, knowing that, I know that I'm going to have my x minus 3 over 3, because this 3 is going to go under whatever number you have. And then my x plus 1 over 3. Well, we can simplify this x and 3 over 3, so I'm going to rewrite my equation like this. And I'm going to get x minus 1. But right here, I'm going to take this 3 and I'm just going to move it in front of the x. So now it's 3x plus 1. So now, let's just cancel out what's common, which is this. So my answer is negative 1 x plus 1 over 3x plus 1. And there's nothing else I can do. So that's my answer to that rational expression. So, seeing that we have rational expressions now, let's move on to what happens when we have to multiply and divide by them. So, multiplying and dividing is pretty much the exact same thing we were just doing. So this time I'm given 2. So I have x squared minus 4x minus 5 over 2x squared plus 7x plus 3 times x squared minus 9 and x squared minus 8x plus 15. Okay, so now looking at all these, factor each one of these as a separate entity. That's all we have to do. So let's work on the top here. And since we're multiplying together, we're just going to draw one line. Actually, never mind. We're going to draw 2 lines. Hello. That's the exact same thing. I don't know why I'm thinking you just do that. It's where brain is not working. So right here I need factors of a -5 that add up to a -4, and I get 5 and 1, and the 5 is negative. So on this top part we have x minus 5 and x plus 1. Well, this one's a difference of squares, so I have x minus 3 and x plus 3. Well, this guy, let's factor this guy out. And this is 2 times 3. So 2 times 3 is 6. We need factors of 6 that add up to 7, and that's 1 and 6. I'm just going to draw one big line. Okay, so factors of 6 that add up to 7. So I would get x plus 1 over 6 and x plus 6 over 6. And then this guy over here, we need factors of 15, add up to -8. And 15, we have 3 and 5, and both have to be negative. So x minus 3, x minus 5. This guy right here can simplify down to 1. This can't simplify, but we can move the 6 out front. Okay. How did I get 1/2? Oh, guys, I messed up. That's a 2. It's supposed to be a 2. And this is supposed to be a 6 over 2. I forgot. I was looking at something different. So there's my problem. So, see, I'm a human. So this is 2x. Sorry. Follow along. I messed up. Fixed it. I needed to put it over the 2, not the 6. So my brain just whoop. So we have simplified and factored everything we can. All we have to do now, find what's in common and cross it off. As long as one's on top and one's on bottom, you can do that. So I have an x minus 5 on top and an x minus 5 on bottom. I have an x minus 3 on top, an x minus 3 on the bottom, x plus 3, x plus 3. Nothing else is matching, so our answer is x plus 1 over 2x plus 1. And that is multiplying. It's just doing 2 steps. Like now you have 2 equations. But it's the exact same thing we were just doing, factoring and getting rid of stuff. That's basically it. And then it just says multiply anything left in numerators and denominators. And we didn't have to do that here, which was nice. Okay, so let's move on to one that is a tiny bit harder. I'm trying to find a good one. Oh, let's move on to a division one. So multiplication, you're just going to do the exact same thing you were just doing. Multiply straight across. This one is a division one. So 2x minus 2y over x squared plus 10xy plus 21y squared divided by x squared minus xy and x cubed minus 9xy squared. Okay, this looks confusing, right? Well, we're dividing, and when we divide fractions, we're going to copy. I'm just going to leave this here, copy, and then dot. We change it, and we're going to flip this. So now on the top, I'll have x cubed minus 9xy squared. And on the bottom, I have x squared minus xy. Well, now it's multiplication. We just changed the division to multiplication. That's the whole point. Because I don't like doing division, I like multiplying. So now, let's factor this. So I'm going to factor the top, draw my one big line. Factor the top here. I get a 2 out of there, and I'm left with an x minus y. Factor this guy. I know that I can take an x out, and that will leave me with an x squared minus a 9y squared. Well, if you look at this is a difference of squares. So, with a difference of squares on this guy, I'm left with an x on the outside, then x minus 3y, because that's right there, and an x plus 3y. So now my top is factored. Let's factor the bottom. So factoring the bottom includes some fun stuff because we have a y squared and an x squared. So what we need to do is I need to find factors of 21. The reason this is a little different, so I know that I'm going to have, because this has an x and a y, so I know in my answer I'm going to have an x and a y. And I like to write them down. So I know that much so far, but we need factors of 21 that are going to add up to 10. Well, 21 is 3 and 7. So, but where do they go? That's the question, right? So the x is by itself, but the 21 is not. So this is 3 and this is 7, and they're both addition. Because when you multiply that back together, you get the xy in the middle and a y squared on the end that equals 21y. So now let's factor this guy. I'm going to take an x out. So I know I have an x. And then once I take the x out, I'm left with x minus y. So now everything's factored. Now let's cross out what we can. Well, I have an x right here. I have an x minus y. And I have an xy plus 3y, or an x plus 3y. So now what I'm left with is 2x minus 3y over x plus 7y. So that is just, this whole thing actually becomes that. That is dividing. Multiplying and dividing, exact same thing. You're just copy dot flipping when you are dividing. So what if we're given a division one that looks like this? People always freak out when they see something like this. We have an x squared minus 1, x plus 3, divided by 5 minus 5x. Well, we're dividing by one thing, right? But we can put anything we want over 1. So I'm going to put this over 1. And now, like I said, we copy this, so x squared minus 1 over x plus 3 dot, which is multiply, and then flip it. So 1, 5 minus 5x. Okay? So now that I've done that, now it's time to factor. So let's factor the top. Factoring the top is a difference of squares. X minus 1, x plus 1, and you're left with the 1 on the other side. This one can't factor, so it's x plus 3. This guy can. I'm going to take out a negative 5. So when I take out a negative 5, I can then rearrange this. And I've done x minus 1. Because when you take out a negative 5, you get a positive x, but a negative 5 from this, you get a negative 1. So I like to rearrange it. And now, let's see what we have in common. Well, it looks like I wrote this down wrong. Again, I always do. I did write this down wrong. Looks like what we have, actually no, I wrote it down right, never mind. I take this and this out. And what I'm left with on the top is an x plus 1, and on the bottom is a negative 5 times x plus 3. And I have just rationalized that expression. Really? All right, so what if we are doing something a little more difficult, like adding and subtracting rational expressions? So basically there's this one method. So if I'm given this, where it says 3x plus 1 over 2x minus 5 plus x minus 4 over 2x minus 5. To be able to rationalize, or to be able to add and subtract rational expressions, it's just like adding and subtracting any fraction. You just have to make sure you have a common denominator. Well, right here, they're common denominators. So the denominator stays the same as 2x minus 5. But now we just have to add straight across. Well, 3x plus x is 4x. And then 1 minus 4 is negative 3. You have just added that rational expression. So it's the same thing with a subtraction. You have to make sure the common denominator is the same. Like, you have to have a common denominator. So if we're given 5y plus 1 over y plus 2, 2y plus 3, and we're going to subtract 3y from it. And we have y plus 2 over 2y plus 3. Well, denominators are the same. So if the denominators are the same, it's going to be y plus 2 over times 2y plus 3. And then we just add, or we subtract 5y minus 3y is 2y plus 1. And that is rationalizing expressions. But what if they're not the same? Because that would kind of suck, right? So if I have an 8 over 15x plus 5, and it wants me to subtract 3 minus 6x plus 2. Well, let's see if we can take something out first of each of these. So I can take something out of these, right? I'm going to take a 5 out of this guy, and I would get 3x plus 1. I'm going to take a 2 out of this guy, and I get 3x plus 1. Well, now that I have that, what I'm going to do with this information, so, sorry, I'm going to make my little fraction right here. I'm going to see if this is weird, but yes. So now that I do with this information is I need to multiply something to get them to match. I have a matching thing, right? But this technically is not matching yet because it doesn't have this 2. So what I'm going to do, I'm going to multiply this side by a 2. I'm going to multiply this side by a 5. Because then that'll make the denominators match. So when I multiply 2 times 5, I get 10, 3x plus 1. 2 times 5 again is 10, 3x plus 1. But 8 times 2 is 16. And 3 times 5 is 15. So now, the denominators are now the same. Just do the subtraction. I'm going slanty again. And you get 1 over 10, 3x plus 1. You have to make them match. That is the whole goal of this. So, you have to find the least common denominator. So here's one of my easier ways that I used to find the common denominator. If I'm looking, this one we're not asked to do anything. This is just saying, well, what's 7, 6x cubed, yz squared? denominator between 9 over 4x y to the 4th and z cubed. Okay, so looking at this guy, what I like to do sometimes is I'm going to write a line here and a line here. And then I'm just going to factor these out. Not really factor, what I'm going to do is list what they have. So the 6 has a 2 times 3, and then there are 3 x's. And that's not an x. And then 1 y and 2 z's. This guy has a 2 and a 2, and then it has an x and 4 y's and 3 z's. Well, to find out what the common denominator is, what I do is I find out what these have in common, obviously, right? I'm trying to see what I did. So I know that this has a 2, this has a 2, this has an x, this only has 1 x, this has 1 y, so 1 y, but 2 z's. So my least common denominator here is 2 x, y, z squared. So that's my least common denominator, right? So what we would have to multiply each side by would be something different. So this side, to get this side to match this side, is we'd have to multiply it by 2y cubed and z. See, this is how I'm figuring this out. And to multiply this guy, I would need this by 3x squared. So once you pull out your least common denominator, then you pull out what you have, and then you figure out, well, this needs to be multiplied here to get the top to match. Well, this needs to be multiplied here to get the top to match, because I've taken out what's common, and that's my least common denominator. It's interesting, huh? That's the way I like to look at it sometimes. I don't know. Maybe you guys don't like it that way, but that's the way I've done it. That's the way I was taught. So if we're given something like this, we're given 4x squared plus 6x plus 8. You need to find the common denominator between 13 over x squared minus x minus 20. So I know I need factors of 8 that add up to 6, which is 4 and 2. So I know I have x plus 4, x plus 2. And this one I need factors of negative 20. Add up to a negative 1, which is negative 5 and 4. So then I have x minus 5 and an x plus 4. So that's on one side, this is on the other. So looking at that, I know my least common denominator is an x plus 4. So I'm taking out my x plus 4, because that's my least common denominator. I don't need to multiply both sides by an x plus 4, but I would need to multiply this side over here by an x plus 2, and this side over here by an x minus 5. So once you pull out your least common denominator, you just multiply either side by what they're missing. And you're figuring out what they're missing by pulling out your least common denominator. Yep. Just making sure I did that right. I'll try not to confuse you guys on how to do this. So let's look at a simple one here. If we're given 3a plus 7ab, well, we need to figure out how to add those. Well, if we pull out our least common denominator, which is a, we're left with a b. I don't need to multiply this to get the b, but I have to multiply this side by b on both sides to get it. Okay? So when I do that, I'm left with 3b over ab plus 7 over ab. Well, now that I have that, I just add. Well, there's nothing in common to add, so it just becomes 3b plus 7 over AB. And we have just added that. I don't know what he's doing up there. So, now that we've done that, that's adding. Let's try one that looks like this. 5 over x plus 3 plus 2x plus 1 over x squared minus 9. Well, we can factor this guy. So I'm going to rewrite as 5 over x plus 3 plus 2x minus, or 2x plus 1. Difference of squares is x plus 3 and x minus 3. Okay, well, what's our least common denominator? Well, least common denominator is x plus 3, so we don't have to multiply by that. So I need to multiply this side by x minus 3 on both sides, the top and the bottom, to get this to match. So now the bottoms are matching, and they are x plus 3, x minus 3. So let's multiply this through here, and we would get 5x minus 15, and now just add. 5x plus 2x is 7x, negative 15 plus 1, negative 14. And that is how we have added those rational expressions together. So it's just finding least common denominator, pulling it out, and seeing what's left over. So let's do a subtraction one, where I have 5a plus 2 over a squared plus 3a minus 2 over a. Oh, a. Oh, so can't do anything with that second part. Well, let's work on this part. So I have 5a plus 2. I'm going to pull out an a, and I get a plus 3 minus 2 over a. Oh my gosh. Second time I've tried to write an 8. So what's our common denominator? Or our least common multiple, sorry. Least common denominator. Least common, oh my gosh. The LCD. Least common denominator. We're pulling out the a. So I just have to multiply a plus 3 on both sides. So I get 5a plus 2 minus 2a. How did I do that? 2a plus 6. Okay? And this is all going to be over a plus 3. Now, just subtract. 5 minus 2 is 3a, and 2 plus 6. See, there's my problem. Because I'm supposed to take the negative through, so it should be a negative 6. Sorry. So 2 minus 6 is negative 4. And then a plus 3. And we have just subtracted. Make sure you're taking that negative through, or it changes your answer like it was about to with mine. I'm throwing things. Okay, so the last part is actually solving the equations using this. So if we're going to solve the equations, I get 1 over x minus 1 half equals 7 over 2x. Well, right here, what's our common denominator? Well, our common denominator is 2x. This already has the full thing. This does not. So multiply this by x, and multiply this by 2, and 2. So now I have 2 over 2x minus x over 2x equals 7 over 2x. Now that I have that, let's ignore the bottoms, because we got them, so they're gone. Ta-da! That's the whole point. You do that, you get rid of the bottom. Once you have the common denominator, you don't have to use them. That's kind of what I'm seeing from my paper. So then I'm just left with 2x equals 7. Well, minus 2, positive x equals 5 divided by negative 1. X equals negative 5. And we have just solved that. So our goal is just to solve it, and then once you get it, you have to make sure you're plugging it back in. So, now that we have that, we have 1 minus 1/5. Oh, I mean 1 over negative 5, guys. Half equals 7 over negative 10. Yeah, I don't know how that's going to work out, but yes, okay. Something like that. That one confused me in mine. I'm hoping I can do this without a second video today because someone's about to call me for tutoring. Okay, so looking at this, what I can actually do, instead of doing the least common denominator with this one, I can just cross multiply. So I get 3x equals 5x minus 10. And then minus my 5x. I get negative 2x equals negative 10. Oh my. And then divide by negative 2. X equals 5. And then you plug it back in. You get 5, because it'd be 5/3 equals 5 over 5 minus 2, which is 5/3 equals 5/3. So you're just plugging it back in when you're done, just to make sure it makes sense. Because what if we have one that doesn't make sense? Like 2 plus 5 y minus 3 equals y plus 2 over y minus 3. Well, I need to multiply this guy right here by y minus 3. So I have 2y minus 6. Looking at the wrong one for a second. Over y minus 3 plus 5 y minus 3 equals y plus 2 y minus 3. So now let's ignore I'm going to put my least common denominator here because we're going to use that in a second. So let's ignore the bottom. We have 2y minus 6 plus 5 equals y plus 2. This combined is a negative 1, so 2y equals y plus 2. Then add the 1 minus the y. I get y equals 3. Well, this is why I need to know what my least common denominator is. Well, my least common denominator here is y minus 3. And this is why we're plugging it back in. Because what did I teach you guys about mowing the lawn without your pants on? Don't do it. Because if we're going to plug this y back in to y minus 3 on any of these, y minus 3 is 0. This is not a solvable equation because we are mowing the lawn without our pants on. So this is a no solution situation. And that, my friends, is solving equations involving rational expressions and just rational expressions in general. So, I'm looking through here to figure out what's next. And it's probably going to be some more radicals, and then we're going to move on to quadratics. But that is how we're going to rationalize expressions and solve rational equations. It's all about factoring, and I taught you guys factoring the other day. Please remember how to factor. Very important.